Okay, let's look at question number 13, part C. So this is where you use de Moivre's theorem, right? Z is given to be this, R is positive, theta is in this range. Then we need to write the complex conjugate of Z, right? So what is complex conjugate of Z then? R cos theta minus I sin theta. So that is Z bar. Then using de Moivre's theorem, we have to show Z to the n plus conjugate of Z to the n is equal to this expression, right? So using de Moivre's theorem, let me write Z to the n. Z to the n is what? R to the n cos n theta plus I sin n theta. Then Z bar n also using the de Moivre's theorem is what? R to the n cos n theta minus I sin n theta, right? So then add 1 and 2, you get the result 1 plus 2 Z to the n plus Z bar to the n. Sine terms cancel, no, sin n theta and minus sin n theta cancel. So you get what? 2 r to the n cos n theta. Right. So that part is done. Hence we have to show what? This 1 plus I raised to the n plus 1 minus I raised to the n is equal to that. So let's write 1 plus I and 1 minus I in r cos theta plus I sin theta form. So 1 plus I, so you can take root 2 out. So half plus, 1 over root 2 plus 1 over root 2I. So this is root 2 cos pi over 4 plus I sin pi over 4, right? So that is 1 plus I. Then 1 minus I is obvious. You don't need to do it again. Root 2 cos pi over 4 minus I sin pi over 4. So 1 plus I is the complex conjugate of, 1 minus I is the complex conjugate of 1 plus I. So now we will use the result, this result. So 1 plus I to the n plus 1 minus I to the n is equal to what? 2 r to the n. What is r? R is square root 2 and theta is pi over 4. Square root 2 raised to n cos n theta is what? Pi over 4. So that's what we want to show, right? We got it, right? Then the last part, substitute what? N equals 2026 and show that this expression is going to be equal to 0. So let's sub n equals 2026. 1 plus I 2026. 1 minus I 2026. 2 root 2 2026 cos 2026 pi over 4, right? So then 2 root 2 raised to 2026. This one can be written as what? Cos 1023 into pi over 2. So this is what? This is a odd multiple of pi over 2. So for any odd multiples of pi over 2, cos value is always what? Cos value is always 0. So this term goes to 0. For any odd multiple of pi over 2, cos is 0. So then this is equal to 0, the expression, right? So this one was not that hard, the more de Moivre's theorem part. Right, next we'll do the differentiation question, question number 40.